In section 7 of chapter 1, we are now going to be solving systems of inequalities. So remember, systems means more than one. So we're going to have more than one inequality, and we're going to be solving them. This is going to look and behave differently than the way that we solve systems of equations. Because equations, when you're solving a system of equations, you're looking for the single location where those two lines intersect. If you remember back when we were graphing linear inequalities, there were an infinite number of answers. So the techniques that we're going to develop later in this chapter will not work on this because there's going to be a large range of answers, not just one specific answer. All right, so here's what we know thus far. If I give you two equations in the following way, this is point-slope form in the old technique, which is in red, and the new format, the new technique, which is in blue, which is what we're going to be using more so going forward. When I look at the red one, I am going to go left 5 and down 2. Since this is on the side of the equation with the y, I do have to flip this value. So I'm going to go left 5, down 2. 4, 5, 1, 2, which is right here. My slope for the red line is positive 4 over 3. So from that point, I'm going to go up 1, 2, 3, 4, right, 1, 2, 3. I don't know where these two are going to intersect each other, so I need a lot of dots. So I'm going to go up another 4 and right another 3. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. And then down 1, 2, 3, 4, back 1, 2, 3. And these are all dots. Oops, shouldn't do that yet. Oh yeah, should do that. We're good. We're good. And then for the blue line, I'm going to go right 7 because I do have to flip this. I still have to flip the number next to the x, but I do not flip the number on the outside of the parentheses because it's not on the same side as the y. So we're going to go right 7, up 4. Right, 1, 2, 3, 4, 5, 6, 7, up 1, 2, 3, 4. This is right here. The slope is negative 1 over 3. So I'm going to go down 1, right 1, 2, 3. I could also go up 1, back 1, 2, 3. Up 1, back 1, 2, 3. Up 1, back 1, 2, 3, and so on and so forth. But that would ultimately get me this line. And what we did is we found the solution, which is where they intersect each other, which for this one is at 1, 1, 2, 3, 4, 5, 6. And this is our answer. We would then plug that coordinate into both equations to verify that. This is what we just got done doing. This is how you find a solution graphically to a system of linear equations. There's one coordinate that they share. As soon as we start doing systems of linear inequalities, this technique no longer works. So let's do a problem involving a system of linear inequalities. You have graphed both of these things before. For those of you taking notes, I highly recommend when I'm graphing these, if you're writing in pen, do not copy what I'm going to write until I'm done. Because if you do, you're going to have a problem. And you'll see why at the end. First, I'm going to graph the red inequality. I'm going to go left 5 and up 1. Left 1, 2, 3, 4, 5, up 1. That's right here. The slope is negative 1 over 2. So from this, I'm going to go down 1, right 2. 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 And yada, yada, yada. So on and so forth. The inequality is a less than or equal to symbol. It is underlined. That means that this line is going to be solid. So I connect my dots with a solid line. Lastly, inequalities have shading. For my inequality, it says that y is smaller than the line. Y will be smaller than the line below it. So I'm going to shade below the line. And this is actually what you do not want to do if you have pen. If you have pencil and a really crappy eraser, you might also not want to do this at this moment. So typically I say if you are uncomfortable with erasing stuff, don't shade until the very end. Now I'm going to do the blue line. The blue line's in slope-intercept form, the y-intercept is -4, which is right here. The slope is 3 over 1. So I'm going to go up 1, 2, 3, right 1, up 1, 2, 3, right 1, up 1, 2, 3, right 1, 3, 1, down 3, left 1. This inequality is a less than symbol, meaning this line is going to be dotted, or in my case, I like doing dashed lines. Notice that these two lines, the red line and the blue line, do not intersect each other at a really nice value. They're intersecting each other at some kind of fractional value. For systems of linear inequalities, we do not care where they hit each other. We don't care. It'll make more sense when you start doing optimization problems, but for right now, we do not care where they intersect. All we care about is roughly the shaded region. This problem says that y is smaller than the line. Y will be smaller than the line below it, so I'm going to shade below the line. So this blue shaded region is the answer to just the blue line. The red shaded region is the answer to just the red line. If you have a system of inequalities, you have to have a shaded region that they both have in common. So what I need to do, and this is why you should not have written this if you had pen, is I need to erase the region that's just shaded red, and I also need to erase the region that is just shaded blue, because I am just looking for where those two regions overlap one another. This graph is the solution. There is no algebra to do. There is no point to test because it's going to produce an infinite number of answers. I should correct myself. There is a point to test, but the point is not the solution anymore. Here's the algebra that you need to do after you do this. We need to verify that that region is correct. The way you do that is you get to pick any coordinate you want in that shaded region. Plug it into both inequalities and ensure that it produces a true statement. My recommendation, pick something that is on the y-axis because it'll have an x value of 0, and typically you want the x value to be 0. It tends to, but not always, makes the algebra easier. So I'm going to pick the point, I don't know, right here. I'll just do something super easy. I'll pick the point 0, negative 10. If I shaded the right region, then that point should produce true statements. So I'm going to plug that into both of them. Negative 10 is less than or equal to negative 1/2 times the quantity of 0, I need to put that in purple, 0 plus 5 plus 1. If that purple point is correct, then when I'm done with this, I should get a true statement. Negative 10 is less than or equal to negative 1/2 times 5 plus 1. Negative 10 is less than or equal to negative 5 over 2 plus 2 over 2. Negative 10 is less than or equal to negative 3 over 2, which is negative 1.5. It works for the red equation. For the blue equation, it'll actually work out a little bit easier because there's no fractions involved. It'll be negative 10 is less than 3 times 0 minus 4. That means negative 10 is less than 0 minus 4. Negative 10 is less than negative 4. It also works for the blue equation. Therefore, the purple dot is in the shaded region.